All right, developers, let's talk WITSML. If you're building apps on this standard, you know how powerful it is. But man, that specification can be a dense read. So in this explainer, we're cutting right through the noise. We're going to give you a super clear architectural breakdown of the WITSML Store API, focusing only on what you actually need to build solid clients and servers. So here's our game plan. First up, we're going to nail down what problem this API is even trying to solve. Then we'll map out the client-server architecture, the fundamentals. After that, we'll open up the developer's toolbox and look at the core functions you'll be using. And finally, we'll get into the rules of the road, the stuff that'll save you from chasing down a ton of errors. All right, section 1. Before we touch a single line of code or look at any functions, we have to understand the why. What was the big problem in the energy industry that made something like this necessary in the first place? At its heart, the WITML Store API is basically a universal translator for well data. Think about it. It's not just about sending files back and forth. It's a really strict set of rules that guarantees when one system asks for, say, well log data, it gets back a predictable, structured answer from any other system. That's the magic right there. That standardization is what makes that right-time data flow possible for making huge decisions. And let's be super clear who this is for. This isn't really for project managers or the business side. This is for us, the IT pros, the developers who are actually in the trenches building the servers and the client apps. The whole thing is written with the assumption that you already get XML and you know your way around client-server models. So that's the angle we're going to take. Okay, so we know the why. Now let's get into the how. We're diving into the client and server architecture. And you gotta understand this part, because everything else we talk about is built on top of it. The whole communication model is synchronous. The best way to think about it is like a phone call versus a text message. With a text, you send it and move on. Here, the client application makes a phone call. It sends a request, and then it just waits. It's blocked. It can't do anything else until the server picks up and gives it a direct answer. And that answer is always one of two things. Here's the data you wanted, or here's an error. That's it. And this breaks down that phone call perfectly. It's a simple 3-step dance. Step 1, the client packages up its request into a specific XML document. Step 2, the server gets it and does its thing. Step 3, the server responds, also in XML. And that's the key insight here. XML isn't just the format for the data, it's the contract. By forcing everyone to use it for both the questions and the answers, the API guarantees that any client can talk to any server. Now, this is a super important distinction for any developer or architect. The API is really opinionated about two things: the representation, how data looks in the XML schemas, and the transport, how it moves using web services. But look at what it doesn't do. It says nothing about storage. For all you server-side developers, this is huge. The spec could not care less if your backend is a fancy database, a NoSQL store, or just a folder full of text files. As long as you speak proper WITSML to the outside world, the inside is all yours. Okay, architecture's down. Now let's pop open the developer's toolbox. These are the actual functions you're going to use to talk to the data store. Think of this table as your API cheat sheet. The column you have to pay attention to is status. The first two functions, getVersion and getCap, are mandatory. Every server has to have them. GetVersion tells you what data schemas the server speaks. GetCap is even more critical. It gives you back a big XML file that lists out every single thing the server can do. It's like a dynamic feature list. The other 4 are your bread and butter data operations, and believe it or not, they're optional. And these 4 optional functions, well, if you've ever worked with a database, you'll recognize them instantly. It's your classic CRUD: create, read, update, and delete. Add to store is your create. Get from store is your read. Update in store is update, and delete from store, well, that's delete. Now, while they are technically optional, let's be real. Any server that's actually useful for managing data is going to implement all 4 of these. Okay, listen up, because this is a gotcha that trips up a ton of new WITML developers. You can't just say, hey server, delete everything that matches this filter. It doesn't work like that. The delete from store function needs the exact unique ID, the UID, for every object you want to zap. So it's always a 2-step process. First, you run a query with getFromStore to get the UIDs of everything that matches your criteria. Then you have to loop through that list and call deleteFromStore for each and every one of those UIDs. All right, last section. We have the architecture, we have the functions. Now we need to talk about the rules of engagement. Knowing the tools is one thing, but the API has a strict grammar, and if you don't follow it, you're just going to get errors. So what are these rules?
Honestly, getting these right is what separates a working app from a broken one, and it'll save you hours of banging your head against the wall trying to figure out what some cryptic server error code means.
Rule number one, the big one. The foundation for everything is permissions. This is a direct quote from the spec, and look how clear it is. The user must have rights. It's not a suggestion. Before a server does anything with a request, it is required to check permissions. If that check fails, it has to stop and return error code -414. Security isn't an add-on, it's baked right into the core of every single interaction. This slide really gets to a core principle of the API. The client has a ton of responsibility. You'll see that word must all over the place in the spec. The client must generate unique IDs. It must make sure a parent object is there before adding a child. It must provide perfectly valid XML. See the pattern? It's not the server's job to clean up messy requests. The server's job is to be a strict gatekeeper. Validate the request, and if it's not perfect, reject it. And this right here is a perfect example of the difference between a may and a must. A client can totally ask for a depth value in feet. A server that's nice may do that conversion for you. But a server is also 100% compliant if it just ignores that request and sends the data back in meters, its native unit. So the huge takeaway for you as a client developer is that you must always check the unit attribute in the response. You have to be ready to do the conversion yourself. Never, ever assume the server will do it for you. And that really brings us to the big takeaway for this whole thing. Building a solid WSML client isn't about coding for the best case scenario. It's about defensive programming. Your app has to handle all the server's musts perfectly, sure, but it also has to gracefully deal with all the mays and the optional features that just might not be there. A server can be totally compliant and not support updates or unit conversions, so the real test is, can your client connect to that server and still work? That is a sign of a truly robust professional WSML application.